Okay, so what we're going to do is we're going to move from pseudoscience to different types of research strategies. And we're going to start with descriptive research strategies, which is how we organize behavior, organize data, observe using observations, and we also describe behavior using different data. And so we're going to talk about a little bit about that, and then we'll move on to the experimental strategies of actually being able to establish cause and effect relationships among variables. Now, I want to remind you that variables are factors that are going to change the things that we're interested in the things that we're actually measuring. So when it comes to descriptive research methods, we aren't able to determine any sort of real prediction. We're not able to look at actual relationships. We're just describing a set of data. You can actually have non-numerical data. You can have a what we refer to as a qualitative data set, which is, for example, you might ask people how they feel about a certain product. And so they might tell you how they feel, and then you can sort of read into that and describe how people like something versus don't like something, if something's working to them or something isn't working. And that would actually not have numerical data. When we're looking at the kinds of things that we use in descriptive data, we can do naturalistic observation. And so this is essentially where you have a group where you're observing them and you're recording particular behavior, but you're doing it in a natural setting and natural occurring behaviors. So maybe you're sitting in a restaurant and you want to see how many people are, using a fork. How many people are talking with others? How many people are on their phone? That's a really good naturalistic observation to make. How many people engage in conversation and make eye contact versus don't. And so what you're doing is you're kind of, looking at a natural environment. You're not making any changes going in there and, manipulating anything. You're just watching. And so, of course, this requires you to be able to identify particular behaviors. You want to actually define what it is that you're looking for. So if you're looking at phone behavior, for example, how many times somebody goes on their phone and uses it, you may say, okay, are we talking about phone calls? Are we talking about just touching their phone and checking the time? Are we talking about somebody playing like a game, using social media? And so you have to define these kinds of observations. And what you can get is a really neat pattern of behavior, and then you can use statistics to actually describe that and see trends. Now, this does allow researchers to study behavior that may, in otherwise situations, be unethical to do in experiment. So, naturalistic observation might be you going and seeing how people respond to a natural disaster, and it's unethical to create a natural disaster. And so this is something that you can do, which is really interesting, that you may not be able to do in any other situation. Case studies are also really great descriptive research methods that allow you to actually take an individual that perhaps have a very rare health condition or very unusual circumstances or an extreme condition, and be able to write a series of pieces on them to understand what is going on with that particular person. So let's say they have a very rare disease, and that's very helpful in the medical field, because let's say only 10 people in the world has this disease. Well, you can write a case study on them, and then if somebody else comes along with the same disease, now you have this case that is very detailed, lots of qualitative information about the person's condition, as well as numerical data, potentially, and then be able to understand a little bit more about what's going on with that particular condition. And we also see this, you can have this happen in unusual psychological cases if they have an unusual circumstance. Now, we're going to cover surveys and correlational methods individually, so we're going to go into a little bit more detail here. Now, with surveys, you can ask somebody's opinion, ask how they behave, You can ask a particular group. So maybe you're interested in teenagers, maybe you're interested in older people, maybe you're interested in a particular ethnicity, male versus female. And so you want to know what's going on with that particular group of people. Usually you have them self-report. You can have them fill out a piece of paper, and they or online in an online survey, and you just ask them a bunch of questions about themselves and how they act. Now, one problem is obviously people lie, and that can be very difficult to get real people's answers. So one strategy to kind of combat that is to ask the same question in multiple ways. And so what ends up happening is the person answers, basically the 5 same questions, and you want to see if they have the same pattern of answering. So you ask the question, you're getting at the same thing, but you're asking it multiple ways to try to sort of trip them up into being honest. How you ask questions, who asks the questions, if you ask it in an interview versus asking it on a piece of paper versus asking it online, all do change how you're going to get a response. If you're asking a young teenager, a young boy, a male teenager, for example, about sex, and you ask him in front of a group of other teenagers, or if you're an interviewer and you are a young, attractive female versus a much older male or a much older female, we're actually going to see different answers. So you have to be really careful if you're going to interview somebody and have them report answers about who you choose to actually run the interview. People tend to be a little bit more honest with computer surveys and if they think that it's completely anonymous. So some important terms when it comes to surveys. So we have a sample, which is essentially you take a piece of the population. So the population is everyone. So let's say our population of that we're interested in is all full-time students at UVA-wise. So all current full-time students. But let's say I want to get just a sample of a few of the students. So you may ask people to take part in your survey, and you send the survey out to the entire population. But let's say you get 100 people who come back and actually fill out your survey. So that's a sample. It's a portion of the population. You could also look at the population and take a representative sample and say, okay, well, I want X amount of freshmen, X amount of sophomore, X amount of junior, X amount of seniors. And then essentially what that is so you're trying to match up the percentages. So that would be representative, because that reflects what your population actually looks like. This would be similar to doing a big scale study in a large city, and you want to get X amount of white people, X amount of African Americans, X amount of Asian, just to reflect what we refer to as a representative sample of the population. And then finally, something that's very important is random selection. And that is every single person has an equal chance of being able to take part in the study. And this is really important because you don't want to be biased in who you choose to be a part of the study. You want those individuals to, to have an equal opportunity to be in the actual study. Now, the last part of descriptive methods that I'm going to talk about is correlation. Now, you may have had statistics and you may have studied correlation, but I just want to make sure that everybody's on the same page. So when we look at correlational, we're looking at relationships between two variables. So we want to see how two factors are actually, how strongly they're related to one another. So when we do correlation, we do generate a number called the correlation coefficient, which tells us the strength and direction of the relationship between those two variables. So what I'm going to do is I'm going to give you guys a couple of examples, and I want to remind you something that's really important about correlation. We can look at the relationship between the two and see, are they related? Are they strongly related? Are they poorly related? Are they not related at all? And it only tells you how they vary in a systematic way. It doesn't tell us anything about cause and effect. So we cannot say that factor 1 causes factor 2. We can only say that factor 1 and 2 are related. The only kind of research method that we can use is experimental that show us cause and effect. So I'm going to show you guys here, before we get into experimental, I'm going to show you guys an example of how it looks for a correlation. So some of you might have had something similar before, and that's fine, but I want you guys to kind of see a couple of different examples. Now, let's say that we were interested in looking at the relationship between ice cream sales and the number of crimes committed, okay? So let's say we were interested in that. Now, I'm going to use an annotation here, so it might take me just a quick second to get this up. Now, so what I want to do with this is a type of graph that you can use to demonstrate correlation, but this is something that makes it a little bit easier to see. But you do run statistics. But I want to show you guys what this, it's referred to as a scatter plot, is going to show us. So let's say we look at ice cream sales, and you can see as it goes up, okay, that would be that higher sales, right? So if we go to the right, that means that there are more crimes committed, okay? And this is actually kind of interesting because we actually see this relationship happening. And I'm going to kind of, just kind of be very general about this. But so every single point that we put on here, and for some reason this is not letting me do it, there we go. So for every single point is actually a data point, okay? So when we match it up, so for every, day that is, we look at ice cream sales, we also look at the number of crimes committed on that particular day. And what we can get is every single little dot here represents an actual data point. And so this would be an example of a particular relationship, and you can see it very clearly here as a positive correlation, okay? And so I'm going to show you guys what we tend to do is draw a line right where in the middle sort of all the data points. So this would be a fantastic example of a positive correlation. Now, what we mean by positive is that it's going in this direction, okay? And remember I said that we have a correlation coefficient, and that would be this number right here, okay? R. So R is our correlation coefficient, and R tells us the direction, meaning is it positive or negative, and it tells us our magnitude or strength, which in this case will tell us how strong these two things are related, okay? So just to kind of start with there. Now, when we talk about correlation, okay, if there is no sign, if there's nothing in front of the period here, okay, the dot, the decimal, that means that this is a positive relationship. And we know by graphing it that it looks positive. So when we run this number, we get a positive 92, okay? That is the number that we get. When it comes to correlation, you can get all the way up to a positive 1.00. That's the absolute highest that you can get. And negative 1.00. Okay? So remember that this number tells us the direction. So the sign in front tells us direction. This is telling us it's a positive relationship, here marked by the positive sign. Positive relationship means that as one variable increases, the other one increases systematically. So in the same way. So in this example, as ice cream sales increase, the number of crimes increase, okay? So this positive relationship shows us that the number of crimes, as the number of ice cream sales increase, the number of crimes also increase, okay? Now, you could say that as the number of crimes increase, the number of ice cream sales increase, okay? So that is the systematic relationship. So does that mean that ice cream makes people commit crimes, or people who commit crimes want to eat ice cream. This is the problem with correlation. We cannot say that one thing causes another. We cannot say that the number of crimes creates more ice cream sales or causes more ice cream sales. We can't say that more ice cream sales cause number of crimes. We can only say that they're related. All that we can say is that they are related in a systematic way. As one increases, the other increases, because this is a positive relationship. What we can never account for in a correlation is other variables. A third variable that might be causing both of these things to change. And we know that this relationship exists. So the thing that actually influences both number of crimes and ice cream sales is heat. When it's a hot day, we actually find that people tend to buy more ice cream and people tend to commit more crimes. And that's because they're very uncomfortable and they get very frustrated. So when people are uncomfortable and frustrated, they're much more likely to riot, they're much more likely to steal, much more likely to commit a crime. So what we know is there's actually a third variable that's influencing both of these things. But we could never know that with just running just a straight correlation. So now that you see what a positive correlation looks like, and you know what that the sign is the direction, either positive or negative, the number itself tells us how strongly these two things are related. So the closer you get to one, the stronger the relationship. Okay? So we have 0 here in the middle. 0 represents absolutely no relationship. So if we look at shoe size and IQ, what we find, I'm going to do a better job here. Hold on. If we look at shoe size and IQ, what we find is a very interesting lack of relationship. That's represented by a horizontal line. There's no relationship here. This would be a correlation at 0 or very close to it. Here, a horizontal line. That would be no relationship. Okay? So this number, so that would be a correlation of something like 0.002 or 0.01 or even 0.1. Terribly low, very low numbers. Okay? The closer you get to 0, the lack of relationship. Okay? The closer you get to 1, you can't go over, but the closer you get to 1, either positive 1 or negative 1, the stronger the relationship. Okay? So this tells us direction, positive or negative. This number tells us how strong it is. Because 0.92 is so close to 1, we see this as a very, very strong relationship. So this would be a strong, positive relationship. Now, the strength does not matter in terms of the sign. So if we have a relationship that's -1, -1 and +1 have the exact same strength, the exact same strength. So if I asked you which one's stronger, a correlation of +1 or a correlation of -1, the answer is they're the same. If we look at this R of 0.92, and if I have a relationship that's -92, and I ask you which one's stronger, you would say they are the same strength. They have different directions, but they have the same strength. Now I'm going to give you guys an example of one that is negative. So I'm going to clear this off. I'm going to show you guys an example of a negative relationship. Okay, So this would be, for example, a good indication is the number of alcoholic drinks. The more drinks that you drink, the worse you're driving. Okay? The more alcoholic drinks you consume, the worse that you drive. Okay? So when you drink very little, your ability to drive is very good, very high. When you drink a lot, your ability to drive is very poor. You see that? So this would be an example of a negative relationship. So if we were to draw a nice line, notice that the line goes down this way, and with a positive relationship, remember here, because I've cleared that drawing, I just want to remind you that this relationship, so this relationship here on the side to the right, this would be a positive relationship up here, okay? And then this would be no relationship over here. It would be just a horizontal line right here, okay? Positive, no relationship, negative. And so here we see negative 0.92 is the same strength as positive 0.92. This is just saying that these two things are related systematically. As one increases, the other decreases. As one decreases, the other increases. So this strength is actually the same strength as the one above that we just covered, okay? But the difference is that this one is negatively related, okay? So your R, your correlation coefficient, tells you how strong and what direction. That's what this very important number is right here. How strong, represented numerically, and what direction. Here we have a negative sign, okay? So this is a quick run through of correlation, and I want to remind you guys with this that the important thing about correlation, most important thing, is that we cannot determine if A causes B. We cannot determine any of that relationship. We can only determine that with experimental method. And I'm going to go into that next, and that will be the next lecture. So just a reminder, correlation is not equal causation. We can only show that things vary in a systematic way. We can use further statistics to predict relationships with correlation, but we're not going to get into that because that's much more advanced. So make sure you move to the next lecture series to learn about experimental